All right, we're back for another awesome video. Wow, so exciting. GPS 2, GPS 2. Okay, it says here determine the cost of proportionality. Okay, and I get the question of that. What does that mean? Okay, well, constant proportionality is. Sorry, I can't even say the word. Constant of proportionality is like saying the constant means the same. Okay, so if I was doing this problem, I look at the table and they're talking about cookies and cost, and I'm looking for something that's the same. That kind of tells me that they want the, well, what's the price for the cookies? Let's say per cookie. And so if I want the price per cookie, I'm looking for the unit rate. Okay, because I want the constant. What are they charging you every single time? Okay, that's what the constant means. Constant proportionality. It's just a fancy word, but you know this word here, constant. You should know it means the same. And so yes, you buy 2 cookies, you buy 3 cookies, you buy 4. You can buy many cookies as you want, but something has to stay the same. There has to be some constant. Well, that's what it means. Something has to be the same. Well, the same means that they have to charge you the same. I don't care how many cookies you buy, but they have to charge you the same for each cookie, that additional cookie you purchase. So if you know that for $1.96 you get 2 cookies, well, how much would 1 cookie cost? And so it's just a simple division problem. Use table and you get the answer. Top in, bottom out. Okay, batallas. Okay, and you get the answer. Bye-bye. All right, next one. Okay, you look at this problem here, you get 2 triangles. Determine the length of ST. Okay, this is ST. I don't know what that is, so I'm going to use a X because I don't know what it is. So I'll just put X for known. That little wavy line there. Okay, okay, they're talking about similarity. So similar. Whenever I see this little wavy line there, similarity, I always think of this. Proportions. Okay, so that means I'm gonna need a proportion, and so that's how I'm gonna solve this problem. Okay, now it doesn't there's many proportions you can set up. There's no perfect proportion, but I like to start with, I like to put the X here. Okay, and then I can compare the small triangle to the big triangle. Okay, or I can compare or I can compare this length with the length of the larger triangle. Okay, or I can compare, like I said, the small triangle, the measurement of the small triangle to the measurements of the large triangle. And in this case, I think I'll compare the small to the large triangle. So X is here. Well, I'm going to say who's in the same position that X is in over here, and I'm going to say BC. So ST is in the same position that BC on the larger triangle. And I know that measurement is 9, so I'm going to put that underneath it. Okay? I'm comparing between triangles. Okay? And so now here, since I used in the small triangle, I used it up here, well then I'm going to use this 3 up here also. Okay? That way I can say, okay, these came from the small triangle and these came from the large triangle. Okay? Keep things in order. And so now this guy here, well, I have to look at the other triangle, see who's in the same position. I can see the 5 is there. Okay, and then it just becomes a simple proportion where you solve the problem by cross multiplying and then divide, and you get your answer. Ping pong papas, fácil, figure it out. Okay, Raymond drove from San Antonio to Dallas in 5 and 2/10 hours. It is 390 miles from San Antonio to Dallas. If Raymond drove at a constant, look at that word again, the key word, constant rate of speed, and did not stop, I guess he never got hungry. How fast was Raymond driving? Okay, so in the real world we use look at that, I can't even write, MPH, miles per hour, millas por hora. Okay, so how many miles per hour? Okay, miles per hour. And so how many miles did he drive? He drove 390 miles. It took him 5 2/10 hours, or 5.2 hours. What is a constant? That means, well, if it took him this long and 5 2/10 hours, what I want to know is the constant rate. That means I want to know the unit rate. I want to know how much 1 mile is. Because if it's constant, that means it's the same. So that means the same. So that means every single hour should be the same. Okay? And so then I just got to find for what's the unit rate. In other words, 1 hour. How much did it take him in 1 hour? Use T when you find the answer. How about that? Okay. Number 4 there. During the month of March, the Jones family used this many kilowatts of electricity. In April, they used this many kilowatts of electricity. By what percent did the number of kilowatts decrease? Okay, so now you have one that's called the percent of change. And you guys that have been in my classroom, you know that I have these charts hanging around my room that I had to take down because of that famous STAR test. But remember, percent of change is just the change over the original. Okay? This word means subtract. Think about that. Okay? Original, what came first? Well, one's in March, one's in April. What came first goes in the bottom. What was the change? Well, how much did you use in March? You used this, and then you used this in April. What was the change? What was the difference? There's another word for change. So a fancy word for change is the difference. Hopefully I spell it correctly for you guys. Okay, what is the difference between these two? And then once you find that, you do T-bow. Yeah, y acabas. Okay. This one here. Sometimes you don't like to see it this way, or write it the other way. Okay, write it this way, or write it this way. Okay, and you'll get the answer. I'm gonna solve it for you. You'll figure it out. Bye bye. Oh, I forgot to check. One more thing. For some of my students, que me la verdad, mira. Guáchale. So there you go. You see? All the time, the best team. Bye bye.